Good evening and welcome to Mrs. Spencer's Math Lab. I'm so glad to have you back again. And if you were with me last week when we worked on simultaneous equations, then I would like for you to look at the problem that I gave you for homework. Hopefully you got the answer. X was 1 and Y was -2. In case you did not get the answer, here's the problem all worked out for you. Those of you who are coming for the first time, welcome. And I pray that you will get something from today's lesson on ratio, proportion, and percents. I choose various topics that I find that students have problems with. And because they have problems with it, I try to unlock that problem. And then they can go for themselves. So, while the others are looking at the problem they had for homework, those of you who are new, I would like for you to get pencil and paper and be ready to begin. Again, another thing you can do is turn your volume up as high. I have my volume up. And then you can click on those two little arrows and make it full screen so that you can see the board better and you can see me better. I am your tutor. I try to make you get a new idea about math because many of you think math is hard. It's not hard. It's easy. It's just that you need to understand it and you need to have the math vocabulary. So that is all that is necessary in order for you to make math easy for yourselves. So those of you who were with me last week, let's look at these simultaneous equations. Simultaneous equations are equations that are solved together. That's what simultaneous means. Once, or occurring at once. They have the same two variables, and the variables have the same values that satisfy each equation. So let's take a look at this. In order to solve an equation, simultaneous equations, we can only find one variable at a time. So what we do is eliminate a variable. Today we can eliminate this variable by simply adding the equations. Positive 3x and negative 3x is 0, so the x's go out. Negative y, 4y, and positive 2y is negative 2y. And 11 minus 7 is 4. And divide both sides by the coefficient of y, and we get y equals -2. Then we have numbered these equations because, remember, the values of the variables have to satisfy both equations. So I'm going to equation 1 and plug in this value for y. And we solve for x, and x equals 1. All right, now to be sure that it works in both equations, I'm going to equation 2 and put in both x and y and see if it balances that equation. So that tells me then that the solution is 1, -2. This is the way we show the values for our variables with simultaneous equations. The first one is for the lower alphabet, and the second one is for the higher alphabet. So x is 1 and y is -2. I hope you did some practice this week, and I hope you were able to get this problem correct. If not, do more practice. Practice makes perfect. So today we are going to do something very easy, and I know when I say that, you say back to me, it's easy to you because you're the math teacher. But when I finish, I hope you'll say that it's also easy to you. All right, today we're going to talk about ratio, proportion, and percents. All right, and I'm going to put a little chart up. Okay. Ratio is the comparison of two quantities by division. The comparison of two quantities by division. And we have the first quantity that's mentioned over the second quantity. And remember this dividing line, this is like a fraction, isn't it? This dividing line is not a line that just divides the numerator from the denominator, but it signifies division. So I could really say the first quantity divided by the second quantity. When I say first quantity, the first quantity mentioned divided by the second quantity. And what we do, we set it up as a fraction and we simplify it in some cases we don't. All right, the units of measure must be the same. So if we have minutes, I'm not going to make a ratio of minutes and seconds. I will have to change so that both of them say the same thing. All right, so we'll get to that a little later. All right, let's suppose we had 6 puppies. And you write as I write. We have 6 puppies. Okay. We have 2 girls, 2 female puppies. And 4 male puppies. Okay. Okay, so this is a problem. We're going to work with a ratio. I want to know what is the ratio of female puppies to male puppies. So you have to be sure you know which way I'm saying it. Ratio of females to males. All right, because that tells me how to write my ratio. So the first thing mentioned is females, and the second is the male. So it's going to be females over males. How many female puppies do I have? I have 2. How many male puppies do I have? I have 4. So the ratio is 2 over 4. Or 2, we write it this way, and we say 2 to 4. 2 to 4. All right, we could also simplify it and say 1/2, because 2/4 does equal 1/2. And so if we did it that way, we'd say 1 to 2. So the ratio of females to males is 1 to 2 or 2 to 4. All right, what's the ratio of the males to the female? Let's do that one. The males, I'm going to change it to just the opposite. What's the ratio of the male puppies to the female puppies? Okay. So this time our ratio is the first mentioned, so males and females. So it's males over female. Okay, and so the male puppies is 4. The female, we have 2. And the ratio is 4 to 2. If I simplify it, it's 2 to 1. How did I get 2 to 1? I just reduced this fraction. Divided both by 2. Okay, 2 to 1. Or we could say 2 to 1. All right? That's simple enough, isn't it? So ratios aren't hard at all. All we need to know is the order of the ratio. And it's just a fraction. The first quantity over the second quantity. All right? Questions? All right. So we have then, now let's do one with measurements so that you will see what I mean when I say the measurements have to be the same. Hope I'm not erasing too soon for you. All right, what is the ratio of 3 feet to 12 inches? Okay, so the units are not alike. So it's certainly not 3 over 12. So when I say units of measure, so I'm either going to have to change both of them to feet or both of them to inches. All right, first thing I'm going to do is change this to 36 inches. All right, so the ratio is the ratio of 3 feet, which is 36 over 12 equals 3 to 1 or 3, 1. All right, now I'm not spending a lot of time on this. We've done fractions. All we are doing here is reducing these fractions. 12 will go into 36 3 times and 12 into itself once. So the ratio is 3 to 1. Well, let's do it the other way. This time I'm going to change this one to 1 foot. All right, 1 foot. All right, my things are falling down. All right, so if I did it with the feet, I'm going to arrange it. I should get the same result. So let's see. 3 feet to 1 foot, which is the same thing we got there, 3 to 1. So either way we do it, whichever way we change it, the units have to be the same. The units must be the same. So remember that if you're comparing ounces and pounds, they both have to be either ounces or pounds. If you're using yards and inches, both of them have to either be in terms of yards or in terms of inches. And that's simple enough. So a ratio is merely comparing two numbers, and all my stuff is falling down. All right, it's comparing by division the first quantity over the second, and remember, if we have measurements, units must be the same. Okay, I'm not going to spend a lot of time on that, because we're going to proportions now. And all of these are related one to the other. All right, let's talk about proportions. All right, we see that proportion is a statement that two ratios are equal. And both ratios must be formed in the same manner, and I'll explain that a little later. Because if we do one way and the other the opposite, then they are not going to be equal. A statement that two ratios are equal. A ratio is comparison of two numbers or two quantities, the first over the second, or first divided by the second. And a proportion is a statement, mathematical statement, that two ratios are equal. All right, so let's see how that works. All right, suppose we had 3/4 equals, and we have a 12 here. Now, in order for this proportion to be a proportion, the first fraction and the second fraction must be equal in value. All right, so we know these two. So 12 is 4 times 3. So we multiply 4 by 3. So we do know that when we multiply 4 by 3, we have to do that to both the numerator and the denominator. So 3 times 3 is 9. Okay, so the proportion is 3/4 equals 9/12. We've been doing that when we reduce fractions without calling it a proportion. But we're going to use this in some problem situations, and you will see what we do with it. All right, let's look at another. 5/2 equals 25. Now, they must be equivalent. So, see if you can figure out what goes here. Always start with the ones that you know and see how they relate. And this other one, it has to relate to this denominator in the same way that this related to the numerators. Okay? Okay, well, we multiplied 5 to get 25. So we multiply 5 and we get 10. Did you get 10? All right, I'm going to put another up. 3/7 equal, and I'm going to put 28. See if you can figure out what the equivalent fraction ratio is. What is the equivalent ratio? So that told you that math is not difficult. It all, just one thing just works right into the other. The ratio is two quantities being compared by division in the form of a fraction. The first one over the second one, first mentioned over the second. And a proportion is just two equal ratios. So let's see if you can find that. All right. So we always start with what we know. We know both new denominators. And this denominator has been multiplied by 4. So we have to multiply the numerator by 4 as well. So we should get 12. Did you get that? All right, I'm going to put 2 more up and see if you can get these. And this is so easy. Question mark over 8 equals 9 over 24. So you can find any part of it if you understand. So we're looking for this one. We're looking for the missing one. What is the missing one number there? And the last one, 6 over question mark equals 3/4. All right, let's see how you did with those. Okay, so actually we're just applying some things we learned with fractions. And I've told you that math is not difficult because if you learn fractions well, ratios and proportions and percents, that's going to be something very easy. Just to understand the vocabulary is all you need, and the processes you've already learned. All right? So again, we start with what we already know. Okay, 8 has been multiplied by 3. Okay, has been multiplied by 3. So what number, 3 times what number is going to give you 9? Certainly you knew the answer was what? 3. All right. Isn't that easy? All right, now let's look at the last one. This time we have the smaller ratio on this side, the smaller numbers. Okay, so 6 has been divided by what? 2. Okay, so 3 times 2 is 6. And we're going to have to do then what? Or maybe we'll go this way and make it easier. 3 times 2 is 6. So 4 times 2 is what? 8. All right. Okay. Very simple. All right. And we're going to do some applications because you're not simply asking on these SOL tests, you're not asked just to find a ratio, but you're given it in a word problem. And we have to learn to read word problems so that we can apply the math. So now we're learning a skill. But in a few minutes, we're going to do some word problems using these skills. So, backing up again, ratios, comparing two quantities by division. And we write it in the form of a fraction. The first mentioned quantity is at the numerator, and the second mentioned quantity is in the denominator. All right? Proportions are two equal ratios. And in order for them to be equal, they must have the same, that means they have the same value. Okay, so let's see if we can apply that to some word problem situations. Okay, let's look at a problem. And I'm not going to write the entire problem. I want to read it, and I want you to make it make sense. Write a ratio for red balls to blue balls. Okay, red balls to blue balls. Okay, so you're given this information. Red balls, you have 10. All right, blue balls, you have 8. And green balls, you have 6. What is the ratio of red balls to blue balls? And this is the kind of questions they ask you on your SOL test. They seldom ask you just simply to find a ratio without it being in a word problem situation. So if I was reading that problem, this is what I would write on my scratch paper. And this is what I would look for to work from. All right, so I want to know the ratio of red balls to blue balls. So the reds are going to be at the top and the blue at the bottom. Okay? So if that be the case, then what is the ratio? Red, we have 10. And blue, we have 8. We could leave it like that, or we could simplify it by dividing both by 2. So right now we have 10 to 8. All right, and we divide both by 2. That's 5 to 4. Either one of those is correct. So whichever one they would have on your test is the one. Now if they had this one, that's the answer. But sometimes they give the reduced form, and you need to know how to simplify. It's just like what we did with fractions. We divide the numerator and denominator by the greatest common factor. All right, let's go to another. Okay, and these are questions that I wrote down because they are kinds of questions that you have on your SOLs. Very seldom do your students just have a problem with no words. So make sure that your children can read math. Which of the following ratios is in proportion with 3 over 4? 3 to 4. Which ratio? So these are the answers they gave. They gave A, 6 to 7, B, 5 to 8, C, 12 to 16, and D, 15 to 14, 12 to 14, and E is 4 to 5. Now, given a problem like this, what do you do? How do you approach it? How do you approach a problem like this? Because these are the kinds of problems that you have, your children have on the SOLs. They do not just find the ratio of 3 to 4 or something. It's always in a problem situation. Very seldom are they just asked to find a ratio unless it's in a problem situation. All right, so we got 3 to 4. That's the ratio. Okay, well, 6 could be at the top, but 7 sure couldn't be at the bottom because 7 is not a factor of multiple of 4. 5 is not a multiple of 3. So that, we can start right out with that. 12 is a multiple of 3. Now, and 16 is a multiple of 4, but it has to be the same multiple. Okay, 3 is 4 times 12. 12 is 4 times 3. And 16 is 4 times 4. So that is correct. But let's see if there are any other answers. Okay, so this is 1. Okay, we have 12 to 14. 14 is not a multiple of 4. We have 4, and 4 is not a multiple of 3. So, and notice how I approach that. I didn't stop because I found one answer, because sometimes there's more than one answer. So always check. When I say multiple, that means that something times 3 gives me 12, and something times 4 gives me 16. Multiples. Okay, so 12 is a multiple of 3, and 16 is a multiple of 4, and both of them are the same multiple. Okay. All right, these are the kinds of things, and this is why, and it's much different from some of the tests we had when we were growing up, because they were more skill, but this is more application. And that's why the SOLs require students to be able to read math well. All right, let's look at another problem. All right, and this is about a recipe, ladies. And sometimes we do have to figure out a pancake recipe. All right, this is a recipe. All right, and it calls for 3 cups of flour, 3 cups of flour, to 1 cup of milk. Okay, and keeping things in proportion, if you want to double this recipe, you want to double it, because you are making a double batch, and sometimes that happens. You're making a double batch. All right, so the ratio of the flour to the, well, several ways you could look at this. If I double it, I just merely multiply both by 2. So if I double it, it would be what? 2 times 3 is 6 cups of what? Flour. And 3, I'll double it, 2, that'd be 2 cups of milk. And we do have to make those adjustments in our recipes sometimes. All right? And, okay, so we have 6 to 2. All right? We could have done it with ratios as well. We could put 3 to 1 equals, and of course, we want to double it. So double means multiply by 2, and that's 6 to 2. So we could do it this way, or we could just merely double it. Doubling and tripling is not as hard as when we necessarily have to reduce it. Sometimes we want half as much, and then that makes another type. We're dividing instead of multiplying if we want half as much. All right, so these are some of the applications that I have. One more I want to do. And then we're going to spend the rest of the time with percents, which are equally as easy. All right, write a ratio. So I want the ratio. I want the ratio. And notice when I read these problems, and this is how I want you to read them. I never read a whole problem because I stop and work on each section as I read. All right, write a ratio for the number of students who received A, all right, to the number of students who received F. Okay, so now I just need some information. The A students, there were 3 students. A is equal to 3. The B students were 8. The C students are 2. The D students 1, and the F students 2. Now this is a problem that they might have on an SOL test, but they ask you to find the ratio of the A students to the F. So the A students to the F. A to F. So it's A students to the F students. Okay? So the A students, we have 3. The F students, we have 2. So the ratio is 3 to 2. 3 to 2. There's nothing hard about this, but again, I say that in most cases on the SOL test, students are asked to read a problem. Much more information is given here than is needed. So the student has to be able to know exactly what they're looking for. All right, so these are some examples of problems using ratio and proportion. I want to spend the rest of the time on percents, and you can certainly go online, as I've told you before, and find some sites that have ratio proportions and do some further practice. The more you practice, the better you are at anything. Any skill takes practice. Cooking, cleaning, driving, math. All these skills require certainly practice. All right, the last of the topics, and all of these are related, is percents. And there's a percent symbol there. Percent means out of 100. It means we could interpret it as divided by 100 or hundredths. And I gave you an example. 6% means 6 divided by 100 as a fraction, or 0.06 as a decimal. All right? And I have something else here that I'm going to work with a little later. All right, but let's just see if we can relate to some percents for a few minutes before we do any problems. All right, if I say 8%, all right, percent means out of 100. So the numerator is 8, and the denominator for percent is always 100 because percent means hundredths. All right, I can write this as a decimal because I know that a decimal, how do I write 8 hundredths as a decimal? I have 2 decimal places, so I have to have a 0 and an 8 because we've already done decimals. All right, so all of these say the same thing in a different way. But all of these represent equivalent values. All right, let's do another. 15%. 15% means 15 over 100 or divided by 100. And hundredths is 2 places, so it means 15 hundredths. Isn't that easy? I told you math is not hard. Once we've had something, we can't forget it. Now that's one mistake we make. Oh, we say, I had that the first of the semester. But that's going to come up again because math is repetitious. It builds on what you've already learned. All right, suppose I gave you this. How would you write that? As a fraction and a percent. All right, this says 25 hundredths, and we have said that percent means hundredths. So that means it's 25%. And how would we write it as a fraction? 25 hundredths is 25 over 100. And there are times that we use each of these in situations. So we need to understand that relationship. We need to understand that relationship because there are problems that we're going to do that sometimes we want to use the fractional equivalent. And here we want to use the decimal equivalent. All right. Okay, so let's see what we can do with percents. All right, the first thing I'm going to do, I'm going to find 25% of 40. Okay? Now, in this situation, this says, the of says times. Remember that. In this situation, the of says times. All right? So really, all I'm going to do is multiply. So I have 2 forms that I can use. I can use 25 over 100, or I can use 25 hundredths. Now in this case, I think I would use 25 hundredths. Makes it easier. All right, so what I'm going to do is multiply 25 hundredths times 40. All right, so we have to multiply by the 0, and I'm going to write it only once. I'm not going to string 3 zeros up there, because 0 times 25 is 25, okay? 4 times 5 is what? 20. 4 times 2 is 8, and 2 is 10. We have 2 decimal places, so we go 1, 2. So the answer is 10. All right, another way we could have done it, and I always show my students several ways. 25 over 100, which is same as 25%. I can reduce that. 25 going, if I divide both by 5, that's one, so that's 1/4. And I could have just simply used fractions and said 1/4 times 40. And that gives me 40 over 4, which equals 10. Okay, so now as a teacher, I would give you credit for either one of these methods. I would give you credit for either one because you have a choice. Unless they tell you to use the decimal, you have a choice of using the fraction or the decimal to find the result. Either way, you should get the same thing. And actually, a good thing is to try both of them, see if you get the same answer, because sometimes we would know that we have worked something incorrectly if we did that. Okay, so that's one type of problem. Okay. All right, let's suppose we had this. I'm keeping easy numbers. 10% of what is 5? Okay, so we got another little situation here now, because this time we know that 10 times something, 10 over 100 times something equals 5. Okay, so how would we approach this? Okay, so this is where I gave, I had a little something there. I had percent. This is a proportion over 100 equals is over of. Now you say, what in the world is that, Mrs. Spencer? Well, percent is always going to be over 100. So whatever the percent is, it's always going to be over 100. So we got 10 over 100 here. Okay. And find the word of. That's the one we don't know. Okay. So that's the question mark. Okay. So the other number is 5. Okay, let's go over that again. The of means it's the number that follows the word of. And that tells us where that goes. It always goes at the bottom. And the other number then would go at the top. Okay, look at that a moment and see what you come up with without my saying anything else. Okay, there are several ways we could approach this. Okay. Several ways. All right, I could look at this. I could look at this. Okay, and I could say, what happened to 10 to get 5? I divided it by what? 2. Okay? So if I divide by 2 there, I'm going to divide by what? 2 here. 100 divided by 2 is what? 50. So that's the number we were looking for. That's one way to approach it. Okay, another way to approach it is from the algebraic way. And let's see how we solve proportions algebraically. All right, percent over 100, that's 10 over 100. Equals 5 over x. Okay? And we know that we multiply, we call it cross. I don't know why they call it cross multiplication, because it's not a cross. It's diagonally. So 10 times x is 10x equals 5 times 100, which is 500. Divide both sides by 10. And if you divide this side, we have x equals, and 500 divided by 10 is 50. All right, and another thing that after you work with it long enough, you will know that when you're dealing with tens, you can just move the decimal point one place. But I don't like to give those shortcuts, because I like for you to understand. And then you can come up with the shortcut after you have done it enough times to see. Okay, so this was 2 approaches to this problem. All right, we have time for maybe one more problem with percents. And next week I'll probably review this. I'll leave that up there for a moment in case someone's copying it. Okay, here's an interesting problem. And see what you're going to do with it. At a home game, and these are the kind of problems that are on those SOL tests. 84% of the seats are filled. Okay, 84% seats. And this is what I want you to do when you're reading a math problem. Don't ever read that whole problem straight through. It's not an English paragraph. There are 5,200 seats. And I want to know how many seats are filled. Okay, so here's the problem. We have 84% of the seats are filled in the auditorium. 5,200 seats in all. So how many seats would that be? Okay. So actually, what it's asking you to define is 84% of 5,200 equals what? That's what it's asking you to find. All right, there are several ways to do that. You could do it with the proportion, or you could do it by just multiplying. And I think of the two, the multiplying, because remember this is, okay. So all we're doing here then is multiplying 5,200 times, all right, and let's use the decimal form, 84 hundredths, okay. All right, multiply that for me. Multiply that for me. See what you get. Multiply that and see what we get for the answer. How many seats are filled? As I said before, seldom on those tests are they just numbers. You have to read something in order to come out with what to do and to know what it's really asking you. All right? So let's get in the habit of reading math that way. Notice I did not read the entire problem. I started writing as soon as I started reading. All right, so let's see what you got here. All right, I hope that you got 4,368. 4,368. That is the answer you should have gotten when you multiply. All right, some of you may have used calculators. And sometimes when you have large numbers like these on a test, they will let you use calculators, but you have to know what to do. Otherwise, you should always be able to be the calculator yourself. All right? Remember, you had to point off 2 places because you had 2 decimal places here. Because the answer you got was 436,800. I'm not going to go through all the multiplication. 436,800. All right, that's what you got. So we have 2 places, none up here, but we have 2 here. So we say 1, 2. And the zeros behind are not necessary numbers. 4,368. All right, so today we have done ratio, proportions, and percents. And all of them relate with each other. We said the ratio was the comparison of 2 numbers or 2 quantities by division. And we write in the form of fraction. The first mentioned item or quantity is the numerator, and the second quantity mentioned is the denominator. All right, then we went to proportions, and a proportion is statement that 2 ratios are equal. And it's just like what we did with fractions. We just make sure that they are equivalent fractions, and we find the missing part. All right, and then percents is another form of a fraction with the denominator always of 100. And I showed you how we work with that. If we find a percent of a number, we merely multiply. Otherwise, we can use that little scheme that I gave you, that percent over 100 equals is over of. I have a quick one here, and see if you can do this. And these are smaller numbers, so you should be able to do this quickly. All right, a team makes 36 shots. Okay, and they missed 42. Okay, missed 42. And I want to know what percent of the shots were made. And just like I'm doing this, that's what you do when you read a math problem. Don't ever just read a math problem like it's an English paragraph, because at the end you will not know anything that you're doing. All right, we've got 36 shots and missed 42. And what percent of the total shots is made? So the first thing, and this is not a trick question, but you have to know that together they made 36 plus 42 gives us what? 78 shots. That's the total number of shots. All right, so I want to know what percent of shots made all right, shots made over the total. Now, before a student can do anything with those numbers, all of this has to go on. And parents, help your children learn to read math, because they know how to find this. But what should probably have tripped them up is that they didn't realize that we're talking about the total number of shots. Okay, so now it's just a plug in. So the shots made, what, 36? Okay, and the total number, 78. Now, one thing we could have done was divide that, because this means 36 divided by 78, and then express that number, which would be a decimal, as a percent. So do that on your calculator, because we don't have much time. And you should get a number like 0.4615 ... It goes on and on. Now, because we're dealing with percents, we're only interested in hundredths. So we need to round off and see all. Just think, a child has to think of all those things because they've been taught this. So we've got to round off to the nearest hundredth. So that's about 4,600 because we're throwing away the rest of this. And we know we're not at the halfway mark because the halves begin with 5. So we call this 46 hundredths. All right? And 46 hundredths is what as a percent? And I don't even tell you to move the decimal point or whatever, one way or the other. Because if you know the relationship between decimals and percents, you know that 46 hundredths is the same as 46%. Okay, because you know the relationship. Now, when I looked at some of these online, they were just told to move the decimal points certain ways and not why. But I want you to know that 46 hundredths is another way to express 46%, and they relate. Okay, our time is about up, and I hope you have learned something about ratio, proportions, and percents today. Practice makes perfect. Please practice. Please go back and look at this. They all hang together. And if you have difficulty with fractions, go back on Facebook or YouTube and look at the videos that I did on fractions. We must understand fractions in order to understand ratio, proportions, and percents. Have a good week, and remember, practice makes perfect.